Okay, I'd like to go through some example problems from WebAssign. So our first one that I chose, a student stands on a bathroom scale in an elevator at rest on the 64th floor of a building. The scale reads 849 newtons. As the elevator moves up, the scale reading increases to 931 newtons. Find the acceleration of the elevator. So let's first pick out what we know. We know the scale when the elevator's at rest reads 849 newtons. That is the weight of the student, so I'm going to label that F sub G. As the elevator moves up, the scale reading increases to 931 newtons. That force, 931 newtons, is actually the normal force on the student. So let's go to the next page and draw a free body diagram. So we have the elevator, there's the scale, and my person on the scale in the elevator. We had the weight of the person was 849 newtons. The weight acts straight down. And when the elevator's at rest, the weight and the normal force are equal. The normal force is really the reading on the scale. So I'm going to write Fn and then write F scale. In our problem, the reading is 931 newtons. The question asks find the acceleration of the elevator. So our goal is to find A. Now if we look at the summation of forces on the person, the summation of the forces will accelerate the student. Now we can get the mass of the student by going back to the weight and dividing by 9.8. So I'm going to take M is equal to Fg over G. That comes from Fg equals M times G. So if the weight is 849 newtons, if I divide it by the acceleration due to gravity, the mass of this student is 86.6 kilograms. So now I know the mass. I'm trying to find the acceleration. The summation of the forces. In the up direction, I have the normal force minus weight will accelerate my system. Anything going up will be positive, anything going down will be negative, just to remind you. So, we have everything we need to find the acceleration. I'm going to take Fn, subtract the weight, and divide by m to get the acceleration. Fn is 931 newtons minus the weight, 849, divided by the mass, which was 86.6 kilograms. If you calculate your acceleration, you have a positive 0.947 meters per second squared. That is our acceleration. What direction is it? It's in the up direction because it's positive. So there's an example. for an elevator problem. It's a little different than the ones we've done in the past. Let's try a new problem. This one, oops, I opened something, sorry. I meant to do that. A crate weighing 582 newtons is resting on a plane, inclined, at 34 degrees above the horizontal. Hang on a second, I pushed a button that I shouldn't have pushed. There we go. Calculate the magnitude of the acceleration, and we're ignoring friction in this problem. So, the inclined plane problem. Let's draw an inclined plane. The angle is 34 degrees. And we have this crate, which has a weight, 582 newtons. So there's my crate. Remember, weight is always straight down. So there's my FG. I have a force perpendicular to the incline, which is my Fy. Parallel to the incline is my Fx. Remember, this angle is 34 degrees, just like your incline. Our goal is to determine the acceleration. So A equals question mark. So the first thing I'd like to do is find the mass of this object. So again, Fg is equal to mass times acceleration due to gravity. So rearranging, mass is equal to the weight of the crate divided by gravity, which is 582 newtons divided by 9.8 meters per second squared. The mass of this crate is 59.4 kilograms. Now, you may remember from class the other day that we want to find Fx along the plane. We're imagining that there is a coordinate system that is oriented, that is really thick, huh? Oriented along the plane. Now, finding f of x. To find f of x, I'm going to use the sine of 34 is going to equal f of x over Fg, which is 582 newtons. Solving for Fx, Fx is equal to 582 newtons times the sine of 34 degrees. So the value of Fx is 325 newtons. That is the only force acting on our crate. So if we look at the summation of the forces on the crate, the only force on the crate is F of x. So to find the acceleration, F of x divided by m will give us our acceleration. F of x is 325 newtons. The mass of the box we calculated to be 59.4 kilograms. And when you do your division, your acceleration of the box down the incline is 5.48 meters per second squared. And that's what we were asked to solve for. The last problem I'd like to do with you is one that involves friction and an inclined plane. Bit 2 is from WebAssign. The question is, a 62 kilogram person on skis is going down a hill sloped at 30 degrees from the horizontal. The coefficient of friction between the skis and the snow is 0.1. What would be the magnitude of the acceleration? Remember, magnitude is just how much. What's the value of it? So let's draw our inclined plane again. And I'm going to make it a little bit smaller. I got a little crazy there. So inclined plane, 30-degree angle. And of course my skier looks like a box. You knew that. What do we know? We know the mass of the person, 62 kilograms. We know the angle, I've already labeled that. We know the coefficient of friction, 0.10. We haven't worked with that yet with inclined planes. Now, things to know. Weight in the downwards direction, Fg. Perpendicular to the inclined plane is Fy. Parallel to the inclined plane is f of x. And I can draw that down here as well. This angle is the right angle. We have a frictional force because we have a coefficient of friction, and that is in the opposite direction of f of x. Now, your Fy is perpendicular to the incline, and f of n has the same magnitude as Fy. So I want to write that down. Fn is equal to Fy on inclined planes. So my first step will be, let's find f of x and f of y. Okay? So I guess I have room here. Remember, this angle is the same as your inclined plane. So my sine of 30 degrees equals f of x over, oh, I haven't figured out weight. So I'm going to move that guy down. Let's figure out weight. Fg is equal to m times g, which is 62 kilograms times 9.8 meters per second squared. The weight of this skier is 607.6. 607.6 newtons. So I needed to put my weight down here. We'll find out 607.6 newtons. A little reminder above it that my sine of theta is equal to f of x over fg. So I'm solving for fx, and fx has a value of 303.8 newtons. Now we have friction on this, so we have to find f of y too. So f of y you can find by using the cosine of 30 degrees equals f of y over, our weight was 607.6 newtons. And again, let me go back a little bit and show you f of y with symbols. So with inclined planes, your cosine of your angle is equal to f of y over, oops, not the normal force, but weight. So solving for f of y, our value is 526 newtons. Now the reason I wanted that is because when I look at my summation of forces on this inclined plane, I have f of x pulling down the incline. Let's see if we can get a... So we have f of x going down the incline, and we have friction going, holding it back. So when I look at my summation of forces, that's going to accelerate our skier. We have F of x down the incline, frictional force holding it back will equal ma. I'm trying to figure out frictional force. So frictional force, let's get another page here. Frictional force is equal to the coefficient of friction times the normal force. But for inclined planes, the normal force is equal to F sub y. So my frictional force is equal to the coefficient of friction for my problem was 0.1. My Fy was 526 newtons. We multiply 526 by 0.1, get 52.6 newtons. That's acting in the opposite direction of F of x down the hill. So now we're ready to solve. Our summation of forces is, made a mistake there, F of x minus the frictional force is equal to your mass times acceleration. Our goal is the acceleration, so F of x minus the frictional force divided by mass will give us our acceleration. F of x was 303.8 newtons. Our frictional force was 52.6 newtons. Our mass, 62 kilograms. Your calculation should give you 4.05 meters per second squared is the acceleration of the skier down the hill. Well, I hope this helps you solve some problems.